Okay, so today we're gonna discuss chapter 3. Chapter 3 is about the eclipses and the motion of the moon. We're gonna be talking about the two type of eclipses, and we're gonna be discussing some parts about the some of the motions in our solar system. So to briefly start with this, when you look at this image right there, you see the Earth and the Moon, and a trivial question would be where would the Sun be located? And as you can all guess, the Sun will be located somewhere here, more to the right of this image, because this part of the Moon is lit. This part of Earth is lit, so the light from the Sun must be coming from the right direction, from this direction somewhere. Uh, so yeah, and this part is in darkness, this part is in darkness, so there is nothing here to shine on those parts. Because I'm pretty sure you all know that stars, they give the light, they shine, while planets, they only reflect the light. Our Earth does not produce any sort of a light like the sun does, and same applies with the moon. These bodies only reflect lights coming from stars, uh, yeah, like our sun. Uh, and this is what I have just mentioned, the difference between a star and a planet or a moon, and so on. So to start with this, I want to talk about the phases of the moon, a very important part of this chapter. You see, the moon takes around 28 days to orbit around the Earth. Let's say the moon is here today. The moon will do this orbit, and this will take it around 28 days. So I want you to forget about all of these phases. I want you to only think about the Earth, this moon, and the sun located somewhere here. If the sun is shining in this direction, this part of the moon will be lit, this part will be in darkness. This part of Earth will be lit because it's facing the sun, this part will be in darkness. So if people are standing here, they're looking at the moon, they will only be able to see this part of the moon, which is in darkness. And this is what we call a new moon, and you can see it right there. This is how the moon would look like. Now, if you wait a few more days, the moon will be moving around the Earth, and it's gonna reach this point. When it gets to this point, go back to Earth. If you look upwards, you're gonna be able to see this part, this lit part of the moon. So the moon will be something like this. Wait few more days, the moon will move to point C. Someone on Earth will look at the moon, he will be able to see even larger part of the moon. Wait longer, same thing applies, and eventually when it gets to this point E, the Earth here is between the sun and the moon. Someone standing here looking at the moon, he will be able to see half of the moon, because half of the moon is lit, and that part which is lit is also directed towards the direction of the Earth, so you would see a full moon. And then as the moon goes in this direction, it will get smaller and smaller, because people on Earth will be able to see less parts of it. So this entire orbit of the moon around the Earth, it takes 28 days. You are more responsible for point A, where I have a new moon, and for point E, where you have a full moon. And you should also be familiar that as the moon goes from a new moon to a full moon, people on Earth will see more and more parts of the moon. So it will be as if the moon is getting larger and larger. While when the moon phase goes from a full moon back to a new moon, you're gonna realize that the moon will be smaller and smaller until it gets to a new moon. This is another sketch for the same topic. If you have Earth, you have the sun. If the moon is between Earth and the sun, people on Earth will be able to see this part of the moon which is in darkness, so they will see no moon, and this is why we call it a new moon. As the moon orbits around the Earth, we're gonna see larger and larger parts of the moon until Earth gets between the moon and the sun. when Earth is between the moon and the sun, people standing here looking at the moon will see this part, the half-lit part of the moon, so we will see a full moon. And this goes on over and over and over again. It takes 28 days for a new moon for a moon to orbit around the Earth. So from a new moon all the way to a full moon is gonna take half of that time, so around 14 days. I hope this is clear now with the phases of the moon. You should know a new moon, how does it work, a full moon, how does it work, and you should also know why we get to see larger and larger parts of the moon, and this is what I have just explained in these 2 slides. Don't worry about the namings here, you don't have to memorize them, these ones. Okay, so let me show you this. Just a simulation. You can go to this link and watch it. So this is a full moon, this is a new moon. Okay, you can watch it and it will become more clear. But if you wanna see this is the new moon here. This is how it will look, because people here will be seeing the dark part of the moon, so we will see no moon. Wait a few more days, you see larger parts of the moon. If you wait longer, the moon will move to complete its orbit, you will see more parts of it, and then you're gonna see, if you are located here looking at the moon, you will see this part which is totally lit because it's facing the sun and it is facing the Earth, so you will see a full moon, and then the cycle will repeat itself over and over again. So yeah, this was about the phases of the moon. Now briefly, second part of this chapter, I want to talk about, very briefly about the moon exploration. What you should know is that in the 1969, Neil Armstrong was the first person to set a foot at the surface of the moon. And since then, around 12 people have landed at the surface of the moon. When you look at images of the moon, you see, these large craters. This is one, this is a crater, this is a crater, this is one, another one, another one. It is full of craters. And even when you look at the moon with the naked eye, you can actually see these craters. And what you should know is that these craters are caused by asteroids that came some billions of years ago. They bombarded and they collided with the moon, and they formed those large craters, those large holes at the surface of the moon. And since the moon has no atmosphere, it has no activity, no rain, no winds, no trees, no life, these craters and these structures will always be there. And they will never be covered unless some external factors cover them. Let me give you an example. The Earth was also bombarded with asteroids, and the Earth was full of such asteroids, but we cannot see them today. The reason is we have biological activity on Earth, we have an atmosphere, we have rain, we have winds, we have oceans, we have water that would cover some of these craters, we have trees growing, and so on. So our planet is active, which this is why we cannot see these craters anymore, although we can see some of them still from space. But when you compare it to the moon is dead, the moon has no life, the moon has nothing moving on it, so these craters will stay there forever or until someone else cover them. There have been 6 missions landed on the moon. In each mission around 2 astronauts landed, and so we have 12 people in total that were able to land on the moon. You can watch this video. This is the structure of the moon, astronauts moving on the moon. You see the sky is dark because we have no atmosphere. This is a mountain, a little hill actually. These are rocks. This is how the surface of the moon looks like. Of course, the gravity is lower at the surface of the moon, so people can move faster and easier, but you just have to adapt for it. In other missions that have been sent on the moon, NASA sent these rovers, and by the way, this is the This is how they landed with this little capsule. But anyway, this rover has also been sent on to the surface of the moon so that the astronauts can maneuver and move to other places at the surface of the moon so that they can study its structure. We go to the moon to study the structure of the moon, to study the rocks, to study the atmosphere, to dig some holes and to know what's underneath that surface. Look at the sky, it is totally dark and black, although it is during daytime. You see, this is the sunlight, so this should be daytime, so the sky should be blue if you were on Earth. But this is not the case, of course, because the moon has no atmosphere, and if it has no atmosphere, then you wouldn't be able to see any of the blue color, because the blue color that we see on Earth is not the real color of the sky or of the universe, it's just the color of the atmosphere some hundreds kilometers above us. Moon has no atmosphere, so you can see directly the universe, which is mostly dark. So yeah, nice. So other than craters that I have just explained to you now, when you look at the moon, you see some dark areas, something similar to the ones you see here, and then you see other brighter areas. While in general, these dark areas at the surface of the moon are areas at the moon that are not receiving much sunlight, so they are not reflecting as much as other areas. These can be valleys, these can be lands that are covered by mountains, so the sunlight isn't being able to shine on these areas, and so these areas aren't able to reflect back to Earth, and this is why we see them more in dark colors. This area, as an example, it is shining too much, so maybe it would be a mountain which is shining and reflecting back more of the sunlight than other areas. So as a general rule, although not very accurate, but as a general rule, you can think of these dark areas as valleys that aren't reflecting any sunlight, or they are reflecting, a small amount of sunlight, while these lit areas, these bright areas, can be mountains or areas that are directly bombarded with sunlight, and so they are reflecting more sunlight, and so they are appearing to be brighter than other areas. Next comes the formation of the moon. So this slide and the next slide, they would explain the same thing, how the moon was formed. And I have briefed the different points out here, so let me guide you through this. This is Earth some billions of years ago, before it had a moon, before it even had light, of course. We called it proto-Earth. And at some point in the early formation of the solar system, there was an asteroid similar to the size of Mars. It came in the direction of Earth, it hit the Earth, and it caused a very large impact, a very energetic, large impact. And because this asteroid was moving so fast, and because it was so large, the impact destroyed the entire Earth, and it set the entire Earth on fire. This is all caused by the collision that happened. And because of that collision, you realize that there are some debris, these are what we call debris, and rocks that were able to escape from that collision. Because of the high impact, because of the high energy, some rocks, not only some, millions of rocks, were able to escape from the Earth. And as they were escaping, they got locked into its orbit. They couldn't go further because Earth has gravity, it's pulling them towards their direction. They didn't go all the way to Earth, so they get stuck in its orbit. So number 3, debris and rocks escaped from the collision, right there. Number 4, the impact tilted the Earth's axis. I'm going to talk about this in a bit. The debris and rocks escaped from the Earth, and this is what happens here. All of these rocks and debris escaped from the Earth. Now they are orbiting around the Earth. After some time, these rocks started to form on each other. They started to stick on each other to form one larger body that we call today the moon. So somehow, if you want to think about it, the moon was part of Earth. And because that asteroid hit the Earth, debris escaped, rocks escaped, they got locked in the orbit. These rocks over time, they stack together to form one body that we call today the moon. This is exactly similar to this one. Earth, straight Earth. You have this asteroid, it hit the Earth, collision happened, high impact, debris and rocks escaping from the Earth atmosphere. Many rocks started to orbit around the Earth. You see, many rocks here, many debris. They stacked over each other to eventually form one body, which we call today the moon. But one important point, look at Earth, how it was here. It was straight. This is the axis of rotation of Earth. But because of the impact, look what happened. The Earth got tilted by 23.5 degrees. Now, this is something, this is really what causes the seasons. It is the tilt of Earth. So if there wasn't an asteroid that would have tilted the Earth, we wouldn't have seasons on Earth, and then things would be completely different. So yeah, this is about the formation of the moon. These two slides summarize in these points. Okay, so we have two or three more topics to discuss. One of them is, I'll tell you about this. One of them is the dark side of the moon. So here's the thing. The moon takes around 27 or 28 days to orbit around the Earth. And at the same time, the moon is orbiting around its own axis. It spins around its own axis. And similarly with Earth, the Earth spins around its axis once every 24 hours. But there's one thing here. Thing is, people on Earth can only see one part of the moon. And this is why we have something called the dark side of the moon. Let me explain this through this simulation. This is the Earth spinning around its axis. This is the moon. We're gonna be assuming three different scenarios. Let's assume that the moon does not do any kind of a rotation around its axis. This is what would happen. If you are on Earth looking at the moon, you're gonna be able to see this white part of the moon, and when the moon gets here, you're gonna be able to see the red part of the moon. So if this was true, people on Earth should have been able to see and should be able to see both sides of the moon. But as a fact, you should know that people on Earth can see one lit side of the moon. And this is why we have the term that we call the dark side of the moon. If this scenario was correct, people should be able to see both sides of the moon, but people on Earth can only see one side of the moon. So this is wrong. So the moon without any rotation is a wrong model. Now let's see another scenario where the moon does actually rotate. Let's see. If the moon rotates, people on Earth can see the red part, the white part, the red part, the white part, the red part, the white part. And this is not the case, again, because people on Earth can only see one lit part of the moon, and the other part is always in darkness. Oops, sorry. Let's see another scenario. So this scenario is wrong. Let's see a different scenario. Now this is moon with rotation, but it is just moving slower. The rotation is slower. So far, it seems that only the red part of the moon is directed towards the Earth. I'm sorry again. See? The moon is rotating, and at the same time only the red part of the moon is visible to Earth. The difference between this and this scenario, in both cases the moon is rotating, but in this scenario, it was rotating much faster than it is rotating today. So the thing is, at some point, the moon was doing this, was rotating but really fast. But as the moon was rotating around the earth was pulling, the gravity of earth was pulling on the gravity of the moon, and it was slowing down its rotation. And eventually what the earth did is that it slowed down the rotation of the moon and it locked it into its orbit. Now the moon takes 28 days to orbit around the earth, and at the same time it takes 28 days to orbit around its own axis. And this is what we call the synchronous rotation right there. So because the moon takes 28 days to orbit around its axis and 28 days to orbit around the earth, only one side of the moon will be visible from the earth. And again, this is what we call the synchronous rotation. And this is something that happens between the earth and the moon, and also between other planets and their satellites and their moons. I hope this is clear. And if you have any problems with it, you can just read more about the synchronous rotation. Okay. So finally, the last part of this chapter is pretty straightforward. It's about eclipses. We have two types of eclipses. We have lunar eclipses and solar eclipses. So let me just show you sketches of both eclipses. Right there is a lunar eclipse. A lunar eclipse, in other words, it is the lunar light that will be blocked. In a solar eclipse, it is the sunlight, the solar light, that will be blocked. So in a lunar eclipse, we have the earth between the sun and the moon. And as the moon goes beyond the earth, in the shadow of earth, the moon will not get enough light from the sun to reflect back to earth, so we're gonna have a lunar eclipse. And in this case, in the solar eclipse, the moon will be passing between the earth and the sun, and the moon will eventually block the light coming from the sun on earth. I'm gonna tell you more about this in the coming slides. So let's see this with a video. When a lunar eclipse, this is what happens. Here people will see the regular phases of the moon, the ones we were talking about. But as the moon goes beyond the earth, we're gonna have a lunar eclipse. Someone standing here on earth looking at the moon won't be able to see much. It will be a lunar eclipse because there isn't any light. You see, someone standing here looking at the moon will see a lunar eclipse because the moon is in the shadow of earth. If I remove the moon and I put it here, then it can receive sunlight to reflect back to earth with no problems. Okay, this is how a lunar eclipse looks like. This is how it started. It started to being eclipsed here, more parts of it, and even more and more until you have a total lunar eclipse. Now the second type of eclipse is the solar eclipse, and as I have mentioned, in a solar eclipse the moon will block the light coming from the sun to earth. So this would be the sketch of it. This is kind of simpler to think about. This is how a solar eclipse would look like. This is the sun. Now this is the moon getting in the way between earth and the sun. You wait longer, more parts of the moon will be blocking the sun, and eventually you have a total solar eclipse, and then it goes away. I mean, if you just try to if you just try to sketch a solar eclipse, it will be much more clear. So yeah, this is what I wanted to cover in this chapter. There's nothing more to cover. We've talked about different topics. I hope it's clear. try to sketch lunar eclipses and solar eclipses, try to watch the videos that I have the links for, and things should be clear. And thank you.